So in our last little mini lecture, we introduced the idea of radio telescopes. So let's talk about radio observatories. The idea of radio telescopes started with Grote Reber really building a dedicated radio telescope. Jansky, though he's started the whole field of radio astronomy, really did it kind of on the side in terms of discovering radio astronomy while working on communications. Reber really built the first radio telescope. But the problem there was that this was right before World War II. When World War II started, then a lot of scientists ended up being called up for military duty. Even if they were not actually serving in the military, though many of them were, they were called up to build weapons and counterweapons, radar and things of that sort. So after the end of the war, you had a lot of very technically trained people, and a number of electrical engineers that were interested in astronomy got together, and they helped to build the first radio observatories, large radio telescopes. One of the problems with radio astronomy is that radio waves are much longer wavelength than visual light, and as we saw when we talked about light, the longer the wavelength, the lower the frequency and the lower the energy. So you need much bigger telescopes to collect the same amount of energy. Double the size of the telescope, double the diameter is 4 times the area, and so that means you need something double the size to get 4 times weaker. Well, radio waves are millions of times weaker than visual light, and so you need things that are millions of times bigger. That makes these enormous instruments. The other thing is, the bigger the instrument, the more precise the pointing. And this has to do with that diffraction we talked about. So what happened was the British government funded this giant radio telescope at a place called Jodrell Bank. And so the radio waves would come in and they'd focus up to a spot there. And you can see this thing is enormous, in size. These are like one-story buildings down in here. And so it gives you an idea as to how big this device was. Now, the United States didn't really have anything comparable to that. Everything in the U.S. was individually funded by a particular institution. No one college or university could afford anything like this. So what happened was the United States decided to establish, through the National Science Foundation, several government-funded radio observatories that scientists could go to. So one of the ones we built was at a place called Green Bank in West Virginia. And so it's in a hollow valley, so iron ore bearing mountains surrounding it, blocking radio signals. It's a no-fly zone, so aircraft can't fly over, broadcasting radio signals. And for that matter, you don't even get cell phone signals or TV signals in the valley. So there's no radio signals. In fact, at the observatory, your car has to stay at the front gate. The only thing you can get near the telescopes would be something that does not give off any radio. Spark plugs give off radio, so you can't use a car with spark plugs. Diesels don't use spark plugs, so they can get close to the radio telescopes, or bicycles. I've been here, and at the dorm that we stayed at, you could either check out a diesel vehicle to drive down, or you could rent a bicycle to go down to the telescopes. The telescope you see on the left here is 140 feet across. So this ledge right there is 7 stories up. So it gives you an idea as to how big that thing is. They also built one that was 300 feet across. 300 foot across was actually, the 300-foot telescope was designed to be a temporary telescope while they were building the 140 foot. And was not very well constructed, but it turned out to be so big, it was the biggest removable radio telescope on Earth, and was able to see things that other radio telescopes couldn't see, so they kept it operating, and they said, well, we'll just keep going until something breaks. Finally, though, in the 1990s, something broke. The problem was it was a very important part, and so the entire structure collapsed. They had the money that year, the government did, to fund a replacement telescope, which is actually slightly bigger, and they call it the Green Bank Telescope, GBT. Now, it's technically the Green Bank Telescope, but in the nature of how astronomers talk about stuff, GBT, they just joke as mean the great big thing. And so in size, the dish is the size of a football field with an end zone. So it's over 100 yards across. It's 100 meters across. It's a little bit more than 100 yards, and focuses all the radio signals up off axis to a detector that's right there. And again, you can see cars and trucks down here, which gives you an idea how big this thing is. The Green Bank Telescope was huge, but long before the big telescope, the Green Bank, was built, there was another bigger instrument built in Arecibo in Puerto Rico. This was a dish that's 305 meters in diameter, so that's bigger than a football field with an end zone. And so it was built in a big sinkhole. And so the idea was you build this thing in a sinkhole, and so you put the reflector up here and reflects all the radio energy to receiver that's up here. Now, originally the receiver was bare. It was not exposed. It was not covered by a little dome like you see right there. That dome was done in the 90s. It was retrofitted. Additional receivers were put in there, heavier instruments, and it was actually heavier than originally designed. And so they had to add additional of these guy wires holding it. And so, but the problem is this only looked up. And so the way you look at something with this telescope is that when you want to look up, you don't have to look just upwards in Puerto Rico, because what can happen is you can move the receiver off to one side, and then signals from this direction bounce up to it. Or what you could do is you could move the receiver back to the other side, and then signals from this direction bounce up to it. Okay, but that means that you're only using part of the dish at a time, not the entire dish. And so this is called a spherical mirror design, and was a very, very worthwhile design. For the longest time, this was the biggest radio telescope on Earth, and featured in a couple of movies, including a James Bond movie even. Eventually, though, China started building something even bigger, and the Chinese telescope was called the 500-meter aperture spherical telescope, or FAST for short. And so it was built in Southwest China, became operational in 2016, was designed to be larger, 500 meters, not 300 meters, and so larger than the telescope at Arecibo, which makes it 3 times more sensitive than the Arecibo instrument. And it became, as I said, became operational. This is kind of a schematic here of the size of the FAST dish to the Arecibo dish. At the time, 2016 became the world's largest radio telescope, and there was just talk at the time of decommissioning Arecibo because it was expensive to keep going. But for national pride reasons, we wanted to keep it because it was the second largest radio telescope on Earth, and the Chinese telescope was not quite fully operational at the time. And then, of course, we had hurricanes that hit Puerto Rico, which did damage, and that was repaired. But then worse things happened. In the fall, early fall of 2020, what happened was one of the secondary cables snapped. So one of these secondary cables snapped, and when the cable snapped, it went crashing down into the dish, and you can see here this giant gouge in the dish as the secondary cable snapped and slammed into the dish. Became very evident that this was going to be very expensive to repair. They were discussing how to repair it, how long to repair it, and how expensive it was going to be, arguments about whether they even should repair it, given how expensive it was going to be. But on the other hand, this was the largest radio telescope in the free world, so they didn't want to just get rid of it. And so became, a political decision. Decisions were slowed down during the coronavirus pandemic, so they weren't really sure what to do. And then as they were working on a decision, structural engineers realized that the remaining cables were only barely supporting the heavy receiver up here. And so they decided that it was possibly too dangerous to work on it, and they were going to see about decommissioning it because it'd be too expensive to try to repair and stabilize and then repair. International group of astronomers got together to petition Congress to come up with the money to fix the thing, but while decisions were being made, worse things happened. One of the main cables over here broke, and when the cable broke, the support pillar snapped in half, and the receiver that was suspended 400 feet up here went slamming into the ground, and the cable sliced through the dish. Basically, it is not repairable. And so the options are to tear down what's left and return this to the natural state of the jungle that's there, or try to come up with money to tear it all out, because you're still going to get rid of it and then build something in its place. And so, but as of November of 2020, the Arecibo Radio Observatory is no longer functional. And so it has been a major blow to astronomy, major blow to the economy of Puerto Rico, because they had tons of people coming to visit the thing every year, a major blow to astronomy education and astronomy research in Puerto Rico as well. So at present, there's no plans to replace it, leaving China as the largest single radio telescope, with the number 2 a very, very distant second. Not all radio telescopes look like big dishes. You could just have something that looks like a Yagi antenna, which looks like a TV antenna that is just pointed up into the sky. And I've seen radio telescopes that are that kind of design. And then this is an array of antennas that are picking up signals from space. So technically, that's a radio telescope also. So some radio telescopes don't look just like what you think of as radio telescopes. Now, the advantage of an array of multiple dishes put together is that it gives you another technology that we call an interferometry. Okay, and that involves the physics of waves. So that'll be our next topic, is how you can put signals from different telescopes together to improve the signal of your radio observatory.